integrity is everything. Our way of life in this country rises and falls on the integrity of our leaders and the integrity of our infrastructure. Because integrity impacts everything, this is the Integrity Podcast, powered by EXO, hosted by Zachary Oliphant.
What an awesome opportunity. Chat on our Integrity Podcast. Got two distinguished guests. I mean, these guys are industry icons. Between them, they've got almost 80 years or 80 plus years in our industry. So I want to welcome Otto Lynch, CEO of Powerline Systems, and Wes Oliphant, which is CTO of EXO. A little brief background on these folks. So let me start with Wes. So Wes is principal and also chief technical officer at EXO, located in Houston, Texas. He began his professional career in 1974 as a civil engineering officer in the U.S. Air Force. He has since accumulated over 46 years of professional experience related to the structural design, manufacturing, inspection, remediation of wood poles, tubular steel poles, pre-stressed concrete poles, fiberglass composite poles, as well as lattice steel towers. In 2010, Mr. Oliphant received ASCE's Gene Wilhoit Award presented by the Structural Engineering Institute for his lifetime contributions to our industry. Wes is also a fellow charter member, Structural Engineering Institute, American Society of Civil Engineers, as well as current chairman of ASCE's Committee of Electrical Transmission Structures. He's also a member of ASCE's Committee of America's Infrastructure, working on and having worked on the 2021 Energy Infrastructure Report Card, and a member of IEEE, where he serves on Subcommittee 5, Strengths and Loadings, to the NESC. So a lot going on there, Wes. Plenty of credentials.
You read it just the way I wrote it.
Yeah. Likewise, Otto, as another industry icon, Otto's got 34 plus years as a distinguished professional. His career began electrical substation transmission line design and construction of numerous transmission line projects around the world up to 500 kV. His professional interest and personal passion for innovation, transmission line design software led to an eventual position as president and CEO of Powerline Systems, and he continues to oversee all areas of the business, focusing on key areas of growth. Otto is a registered professional engineer and active member of ASCE, IEEE, ANSI, and other technical committees, including the ASC 48 Steel Pole Transmission Structures Committee and the ASC 10 Lattice Steel Transmission Structures Committee, where he's currently vice chair. Otto is also a voting member of Subcommittee 5, as well as the main committee of NESC. And Otto was a recent recipient of the ASC Walter P. Moore Jr. Award in recognition of his technical expertise in development of structural codes and standards. That's a lot. I mean, we can almost fill the whole podcast just on y'all's credentials. I thought maybe it would make sense, Wes. I mean, you and Otto go back, have a big history together. Maybe you just introduce your personal relationship with Otto, maybe some of the things you guys have done, and Otto, maybe we'll have you do the same.
Well, I was thinking about that because where did you and I meet? I think it was on a beach in California somewhere at a conference, and Doug Sherman and I think, and we ended up walking the beach, drinking a beer, and talking about all the things that needed to be done in our industry, right? And from there, it's flourished, I think, almost 30-something years now.
Something like that, yeah. And I think we solved all the problems.
I think we solved all the problems.
We solved all the problems.
Didn't have any more to solve after that.
Yeah. I think we may have maybe indirectly met before that, just at industry meetings and stuff like that. Of course, I knew of you and your reputation. But yeah, we ended up at that meeting in California, and you, me, and Doug just had a nice evening, and we just walked the beach and got to know each other personally. And exactly. I've been very fortunate to have Wes as a friend ever since then. So
likewise.
Well, fantastic. Well, maybe, Otto, we start with where did your career begin? I mean, I think that's always interesting discussions. And when folks have been dedicated to industry as long as you all have, hearing your origin story, I think, is really meaningful.
Sure, yeah. My dad was a land surveyor, and so probably about 8 years old, I started working for him and working full-time summers, and he picked me up after school on some days, and I would be the rodman holding the rod, and often held the dumb end of the tape, as he would say, and take this, and he had the smart end. And I finally got promoted to chief transit setter-upper, where I would get to set the transit up and level it and get everything all set up while he was in the truck doing the calculations for what we were going to be doing. And so I grew up in that industry and really enjoyed it, just absolutely loved it. And I thought I was going to be a surveyor. My dad did own his own survey or company, I should say. And I probably was about 14, I was like talking about, okay, what are we going to do when I get old enough to get in here? And he said, well, you tell you what, you go to school and get your engineering degree, and then we'll talk about you taking over the business. He's like, you need to do more than that. And he had missed the opportunity to get his degree in engineering, and so he wanted to make sure I had that opportunity. And so probably about 14 or so, and so it's like engineering, okay, civil engineering. All right, what do they do? Well, they design buildings and bridges and dams and, as I say sometimes, targets. So we build the targets. And so I went to Rolla, ended up going to Rolla, University of Missouri, Rolla, UMR. Now it's called Missouri S&T, Science and Technology, but we still call it Rolla. Which, by the way, is where my son's going to school right now, so
awesome.
He's following my footsteps on that. And so really liked civil engineering, got into the structural side of it, really enjoyed the structures part of it. And came time to getting ready for graduation, I started doing all the campus interviews with any company I could get an interview with. And I thought I was going to be designing buildings and bridges and maybe a dam or two. And I even had one very interesting lead. I shouldn't say I got the job offer, but it was an interesting lead to design sports stadiums. And I was kind of like, oh, man, okay, I love football, I love baseball, and I could design a sports stadium. So it was very interesting. But then, I don't want to say my last interview, but finally Dave Kaler from Black & Veatch came, and I'm sitting there telling him what I want to do, and he goes, I want somebody to design transmission lines. And I was like, I had one class in electrical engineering, and I slept through it. This is not what I'm going to be doing. I'm going to be designing bridges. And anyway, I told Dave that, and Dave said, no offense to any electrical engineers out there, but Dave said, once you size the wire, everything else is civil structural. And
that's a good way of putting it.
And then Dave went on to say, it's like a bunch of suspension bridges, and you get to do everything. All disciplines are involved. And sure enough, we're talking surveying, geotechnical engineering, grading, structural design, construction management, and Dave also told me, he said, if you do this, you're going to get to do a whole bunch of them. Yeah. If you design bridges, you may design 4 or 5 bridges in your life. And he goes, you do this, you're going to be doing 4 or 5 transmission lines in your first year. Mm-hmm. And that really attracted me. So when I graduated, I took that job and went to Black & Veatch, and that was in 1988, and been doing transmission line engineering ever since.
So walk me through. In 1988, you're new engineer at Black & Veatch, and you've got to go design transmission line. What tools were at your disposal at the time to go do that? Things have certainly changed since then.
Well, good grief. I was never afraid of computers. Luckily, I was right at the generation in college, and we had a very, very early CAD system, and I just loved it. I enjoyed doing things like that. So when I got to Black & Veatch, they were like, oh, we got this new little program. It's called Tower. But it's DOS-based, and you have to slide the floppies in for each thing you do, and nobody else wanted to touch it. And so to answer your question, I started doing Lattice Towers almost immediately.
Okay.
And using what is Power Line Systems Tower software. And that's Dr. Pro had done that many, many years ago. And like I said, it was DOS-based. You had to flip a floppy out anytime you did you do the coding, and then you do the analysis, and then you look at the graphics. And, we thought that was the greatest thing since sliced bread. And people now are like, yeah, but that takes 2 days. I only have 2 minutes. So it's kind of fun. But that's how I got involved in the software side of that.
Sounds good. So you're a junior engineer at Black & Veatch. You start designing transmission structures. Kind of what's the next iteration in your career? So you're doing that for a few years. You get that experience under your belt. And then where does it go from there?
Sure. Black & Veatch had kind of I don't know if it was ever written or unwritten, but basically it was understood if you wanted to advance in your career, you needed a field assignment. You had to go out in the field and get your boots dirty and your Carhartt dirty. And another a blessing that just happened. A good opportunity came up, a 100-plus mile 345 kV line from Corpus Christi down in your neck of the woods. And so I got the opportunity to go there for a year and a half and be the resident engineer on the project. And I was there early enough, even helping right-of-way agents acquire right-of-way and clearing and drilling foundations, soil borings to get the foundations, and eventually the structure construction and erection. It was both lattice towers and tubular steel, wire pulling, and all the way through the final commissioning of the power line. line. And to see that from beginning to end was a great experience. And just learning from the linemen. I mean,
Absolutely.
I would just sit there and, I was like a sponge, teach me. And they were having fun teaching me. And, I just learned so much more out in the field. You can sit in a desk for 10 years and never learn what you learn in a month out in the field.
It's certainly a common thing we hear from a lot of folks that we sit down and chat with. It's this: get out in the field and go experience the actual work being done.
Yes.
Now, was this a line you designed,
Yes.
and then you're seeing it get constructed as well, or you were participating?
I was
in the design?
one of the engineers on that
Okay.
project. I wasn't the engineer. That was a little bit before PLS CAD, and so it took about 10, 12 people to do a decent project. It wasn't a one-person job.
Back when you're using templates for plan and profile
Yes,
drawings.
plastic templates, the slide rules of our industry. Yes, we were using templates, and that was to kind of get back to your earlier question. That's why there was this little program called Lotus 123, and nobody wanted to touch it. So I wrote spreadsheets for like how to, foundations. We're talking construction schedules of the diameter and the depth of all the foundations and the pole lengths from the center hubs, and wrote big spreadsheets that just basically. We used the spreadsheets and really didn't even have to get too much into the drawings because you could just follow the schedules. So I was using Lotus to do a lot of stuff like that and just loved it.
Tell the story, Otto. You had mentioned it to me before about when you're working for your dad, pulling the chain, doing the surveying, but you didn't know it at the time, but that was your introduction to sag and tension on cables.
Yeah, I was just thinking about that last night, matter of fact. And when I was, 8, 9, 10, back then we didn't have theodolites and everything else. We had to pull change. And think about a 300-foot long steel tape. And at that point in time, you had to pull it up to a certain tension. And we even had a scale, like a fish scale, if you want to call it that. And you had to pull the cable to that certain tension. And you had to hold it really high because of the sag of the tape. And then you had to hold a plumb bob, and you had to pull 30 pounds and hold a plumb bob right over a pin this big around. And as a 10-year-old skinny kid, that's kind of hard to do. And,
Your dad yanking on
he
the other
yanked
end.
it. Yeah, if I wasn't doing a good job, he'd yank it. I was like, I got to start all over again. But that, physically and everything else. But we'd do that, and we'd calculate. We'd have to know the temperature outside. With pulling that tape in December is going to be a lot different than in July, and sometimes we wasn't pulling the full 300, we might be pulling 200 or something like that. Mm-hmm. And so at that time, we didn't have sag tension software, and it was basically a set of charts, and we look at the charts and do a calculation. And so instead of pulling 300 feet, we might pull 300 feet and 4/10 in order to get the proper sag and the elongation of the chain and everything else to take that into account. I didn't really understand what I was doing back then, but we were doing sag tension calculations.
Yeah, which obviously is a great corollary for what you do today on the transmission business, right? Where you're doing the same thing with conductor, yes. Right? Steel and aluminum conductor and how they're affected by heat and tension. So you are involved in this big project in the field. You learn from all the line guys, which those guys will teach you so much spending time in the field.
You can teach you stuff you don't want to know.
Oh, yeah. I learned a lot of four-letter words.
So you complete that project. I'm sure it was a success. And then kind of walk me through the next steps. So you've got the field experience. You've got kind of the line design experience, those two now. And
yeah, I got back to the office and sure enough got promoted pretty quickly and got involved with a lot of international projects and not just doing the work, but also like in working in the preliminary stages and helping to site and working with clients. And which, by the way, back on the field assignment, one of the skills that I learned was social interaction, yep. Learning how to work with the linemen, learning how to work with the contractors, learning how to work with really mad landowners, and just learning how to handle different situations. There's a lot of credibility in that. But, that getting back to my international assignments, it was just kind of fun to work with different people around the world and understanding the different cultures. I got to go to Thailand for several stints, and those were kind of fun. We were looking at siting power lines, and I was working with the power plant group. So we were looking for places to put a power plant so that it would be close to a cooling source and have all that together at the same time, not too long of a transmission line for an easy interconnect into their existing grid. And spent several months tromping around the back of Thailand looking for places like that, and a lot of fun, a lot of cultural experience and stuff like that. So I got a good opportunity for that, and then ended up working in a lot of regional office, worked in Dallas, worked in Orlando, worked in Ann Arbor, Boston, worked in the Boston office for a while, just working on projects locally, a couple of week assignments on a week on, week off and stuff like that. And eventually they promoted me to manager of transmission lines in the Portland office. So we moved to Portland. And that was a lot of fun. Got to manage a lot of projects and people and stuff at that point in time.
Now you go from being obviously a junior engineer, now you're a manager, and then walk me through the transition to PLS. I mean, how did that come about? You've been obviously using their software since the early days.
And that's, like Wes said earlier, I was using PLS, I've been using Tower, and got to know Dr. Perot, who's the founder of the company, and probably in '92 or so, he gave me a floppy and said, "Here's a line design program that I've been working on. Would you play with it?" And I was like, "Sure." And it was PLS CAD, and at that time it was called Computer Aided Line Design,
yeah,
CALD.
That's what it was, yeah.
But it eventually became PLS CAD, and so I'm sitting there playing with it, and I was like, "This stuff is cool." And Alan, and his son Eric, who was doing a lot of the programming, I just started helping them and saying, "Hey, you need to do this. It'd be awesome if you could add this feature. It'd be nice and helpful if you did this." And so just over the years, I was helping them develop the software just from a practical side of it, and it was a lot of fun working with them. And then to answer your question, probably around 2000, long story short, Alan and I got to talking, and he said, "Hey, what would you think about coming to work for me?" And I was like, the only thing I know about C++ is how to spell it. And Alan, Dr. Perot said, "Exactly. We've got the software programming expertise. We just need somebody that can do everything else." And so very difficult.
Somebody to understand how it works and how it's going to be applied in the field.
Yes,
right?
and continue to bring more closer engineering applications to the software to make sure that it was dovetailed together to be productive. And so, I made a very, very difficult decision. It was a hard one to make, very hard one to make, but I decided to leave Black & Veatch on good terms, very good terms. I've been with them for 12 years and made a lot of good friends and a lot of people that my peers that I've respected. And took a cut in pay, a major cut in benefits, but I believed in it. It was
went to work for a little startup up in Madison, Wisconsin.
Yeah. It was. I wouldn't call it quite a startup. It was a little bit, but at the same time, it was a risky company. Okay.
Yeah, Dr. Perot was still a professor, wasn't he, at the University of Madison? Or
yes, he was still a professor at the university, but he did retire shortly after that. Okay. And but it was a huge risk to do that. But like I said, I believed in it, and I knew what it could do, and just seemed to be the right thing to do. And like I said, it was very hard to leave Black & Veatch. Great company, and I didn't burn any bridges, and I'm still good friends with all the people that are still there.
Yeah, I bet. I mean, it's always a tough jumping off point to do something like that. I mean, Black & Veatch being such a large consulting organization, and you were growing your career there really effectively. But to have the vision to say, I want to go do something different and really do something revolutionary with the software that they were building, you were helping them build, is really fun and impressive to see. So kind of flash forward, now you're at PLS and getting involved in their business and helping kind of run the day-to-day. Kind of walk me through that to get us to where you are today.
Well, that was kind of another one of my opportunities. I've just been unbelievably blessed at different parts of my life, just the right place at the right time, making the right decisions, and not always, but made a few wrong ones, but most of them have been good. But that was a good time, and Dr. Perot was looking to slow down, to eventually retire, and he was very active in the industry, and I had been somewhat active when I was at Black & Veatch. I was going to ASE meetings, IEEE meetings, and participating, but Dr. Perot basically said, "Hey, I need you to start taking over some of my committee membership participation." And so the first one I jumped on was 48, tubular steel pole, and eventually got on ASE 10 and some other ones throughout the time. But the whole doing that was trying to make sure that our software was always current with the latest codes and standards, and be able to help the industry move into the next generation on, especially when it comes to using computers and software to do design and analysis and stuff like that.
I think that's one of the areas that Otto and I both, you talk about the right place at the right time, but we both started when there were no such things as computers, essentially. I mean, I'm a few years older than Otto, so I didn't have a calculator even. The calculators didn't even come about until I was a senior in college. So from calculators to computers now to really sophisticated software that does these things, it's been a pretty transformational move for us as an industry, hasn't it?
It has, and it's changing every day. I mean, with all the other things that are going on, and integrations and AI and everything else, and a lot of people dream, and I'm like, it's great to dream, but sometimes we need to control those dreams and take them in step processes. But it's a rapidly changing industry.
Walk me through just a little bit, Otto, for maybe folks that don't use PLS software today, just kind of elevator speech on what the software does, what value it brings to your clients. I mean, you guys are kind of the leading folks in the world on line design software. Maybe just kind of pitch that for a second.
Sure. Probably the best way to describe it is it does everything for overhead line design. And as I mentioned earlier, we're talking surveying, terrain development, foundation design, geotechnical, structural analysis and design, wire, stringing, sag tension analysis, of course, with all the construction reporting that's required so that the linemen and the folks in the field can build a line, all the way to documentation, and of course today with GIS and the digital twin being the digital twin of what was built out there. So we pretty much handle all of that. I mean, we're both a horizontal and a vertical company. We're horizontal. Everything we do is broad. People say, okay, buy our software. What other programs do I need to buy? And, do I need to buy another sag tension program? No, we got it all. Do I need to buy a foundation program? No, we got that. Do I need to buy something to handle the mapping of my GS application? No, we got that too. So we kind of do it all. And so in a nutshell, that's what we do. Of course, I can go deeper, but in a nutshell, that's what we cover.
It's a lot more complex than most people think it is too, isn't it? I mean, just calculating the catenary curve of a conductor is one thing, but then now putting it on a structure that's moving around is another thing, yes. And being able to take into account the temperature changes, yes. And how that affects the wire. That's built in.
It's all built in. Thank you. And golly, it's amazing. People think that transmission, you're just stapling wires to the poles. No, it's so complex. I mean, my son's majoring in mechanical, and what do they tell you in mechanical engineering? Don't mix two metals. And what do? We take a steel core and wrap aluminum around it and then change the temperature up to 300 degrees Fahrenheit. Mm-hmm. We break every rule on that comes in, but that's what we're able to calculate as the wires heat up and cool down, the change in the different metals and how they behave, as well as wind blowing out the conductors and ice on the conductors and combinations of wind of ice, and especially in today's world with the vegetation analysis. And, the wires don't stay where they are when you go survey them. Yep. We have to know when it gets hot, when we're having those hot days in September like they are in California right now, how far is that wire going to sag down? Yeah. When you get that, maybe not a Santa Ana wind, but when you get a strong wind combined with that, how far is that wire going to blow out? Is it going to blow into the vegetation, the trees, or hit too close to the ground? And that's what we do. We can create that entire wire movement envelope. And as Wes said, it's not just the wires moving, it's insulators swinging out, and it's poles deflecting. Yep. A pole can deflect 10, 12 feet easily underneath a higher wind. So add that 10 or 12 feet to a wire that's blowing out 30 feet, you're outside your right-of-way all of a sudden.
Yeah, absolutely. And it's interesting to hear you talk about this, Otto, because you guys are really synthesizing all of this complicated data into something that makes sense, right? And in a lot of ways, there's corollaries to what we do with all the data we collect on the field side. Maybe, Wes, you can speak to that a little bit. I mean, it's very different than what Otto's doing on sags and tensions and loads. But same thing, you get all of this complicated data and you've got to synthesize it into something that makes sense to be able to deliver something to a client, right, that's meaningful.
Yeah, well, I mean, we've used PLS CAD for doing some of our failure analysis. We just presented a paper this morning at TS DOS here that talked about that when you have a failure of one structure, what it does to the adjacent structures. And we modeled it in PLS CAD to show that when that one structure started tilting over, how the loads changed on the adjacent structures. And that was critical to understanding what caused 14 structures to fall down, because otherwise you don't know. And we look at it From the health side, obviously, you and I have talked about that a lot. You look at it from new construction and everything is still in good shape. At some point, we're going to merge our technologies together and find out, okay, it's good when it's new, and here's what it looks like when you've got 20% degradation happening on something. And we collect a lot of data as well. We do very similar things, but not to the extent of involved in the line design part, but just in how to keep that structure healthy.
Yeah, no, absolutely. So, Otto, one of the things I think you bring a unique position to the our industry here in the U.S. is your global perspective. I mean, your software is used all over the world, leading software, and maybe walk me through how it's maybe different than what we deal with in the U.S. Other places that you guys participate in, and I know you've got friends in Europe that are having a really interesting, energy crisis right now with everything going on in Ukraine. Maybe give a little commentary there.
Let me just add before you answer that question. I think, and you can chime in as well, but power lines are the same all over the world, essentially, right? Everybody builds them essentially the same way, maybe different voltages, but we all have the same problem. It's a global energy grid that we're dealing with, and so I'll let you go ahead and.
No, that's very true. Something I say all the time: a wire is a wire is a wire. Structure. Wood is wood. Steel. Wind is wind. Ice is. It's no different in Europe than it is here. They may have more of it. They may have less of it. They may have different combinations depending on their geographical region. Of course, some people in the world don't have any ice at all. They're really lucky because it's a lot easier to design when you don't have ice. But you throw some ice on something and it becomes quite a difficult puzzle to solve. And then the other thing that probably the more difficult part is when it comes to codes and standards. We're kind of talking about ASC codes and standards, and what Wes and I have been involved in for 20 plus years now, more for you. We have our codes, but not everybody in Europe follows our code. They have their own codes, and they believe that wind blows differently. And I don't mean that negatively. I'm just saying, we have our code where when you get higher, there's a certain equation that increases the wind speed, just because it's a function. Whenever you go up on top of a tall building or whatever, it's windier. But there's also less gusting. It's less responsive. It's more straight winds up high. There's not anything to. And then, we here in the U.S., we pretty much use ice, and it's a fixed number, and we typically don't apply it to the structures. It's very insignificant when you look at it overall line design. You get in Europe, and first of all, they say, well, ice changes with height. Not just wind, but ice changes with height. And they have different equations for what they believe the wind changes. And I'm not saying we're right, they're wrong, they're right, we're wrong. They're just different. Different philosophies and different ways of approaching the situation. And then in Europe, they actually change the ice thickness with height. And that gets really difficult. But we do that. And I'm just saying Europe, since you asked that one, but every country just about is different. Even in Europe, there are different countries. They have a standard, but then they also have what they call an NNA, or a national normative, where Belgium would say, well, we use the standard, but we change these 10 things. So we have to have an NNA for Belgium. We have to have an NNA for Germany. We have to have one for France. We have to have one for all these different places. So even though they may use the same code, they still make their own tweaks, and keeping up with that is quite difficult, to be honest. But that's why we are where we are, because we do that all around the world. And just to wrap that question up, Australia, New Zealand, you start talking about other places, India and stuff like that. Every one of those places, we have to adapt their codes and standards. Same stuff, same design applications. It's just different ways of calculating what that wind increase is going to be or whatever.
And I think, just to add to what Otto's saying, I think that's one of the values that we're starting to see in the ASCE codes and standards, because we have people that are involved in international work that now know this is what they're doing in Australia, this is what they're doing in Belgium. So I think from that standpoint, it's helpful that we look at all the different points of view and try to understand, not anybody's right, everybody's right, but I think at the same time, it's good to hear what everybody's different ways of doing things are. We can make it maybe some composite of that at some point in time.
Absolutely. So you talk about the global perspective there, Otto, and then let's talk about the U.S. I mean, the U.S. Energy grid is changing very rapidly. And we're in a scenario where it's a very old industry, but it's going through some very robust changes. All of the renewable energy that's come online the last 10 or 15 years, maybe a little longer, but 10 or 15 years. We've got EVs being rolled out in huge numbers. All that's putting pressure on the grid. And then, as we speak today, I mean, there's record, high temperatures out in California, 125 in Death Valley. I think it's almost a world heat record. And that puts major stress on our grid. Maybe just give a little bit of insight on kind of all of that complexity and what you're seeing in the industry.
Sure, and it's a little bit of everything, and that's what makes it so difficult to keep up with. I mean, probably the first thing is our infrastructure is old. It's very old, like most of our infrastructure. The only thing is when you're talking about power lines, you drive across a bridge. If you're like me, you're looking at the underside of the bridge and you see the rust, okay? And I know you guys are like that big time, okay? And we can see all that stuff. We feel, to the average person, we feel every pothole. Yep. That's infrastructure aging, okay? And we can fix that. Think about all the potholes and the rusting that's going on transmission lines when nobody looks at them, and I say potholes, obviously not potholes figuratively, but literally, or I should say literally, but figuratively, what we would call a pothole. And so we've got these lines that are 50, 60, 70, 100 years old out there, and they need to be replaced. They need to be, maintained. Some of them just need to be flat out replaced. And not jumping off topic too quick here, but it's not like we can just tear it down and build a new one because our grid is so full right now, so at capacity, we can't take it out of service. And so we got that going on. As you mentioned, we have renewable energy going on, and you can't just mothball a plant in Ohio, coal plant, and build a wind farm right there. You got to build a wind farm out in Kansas or Oklahoma. Well, then you have to get into how do we get that power back to Ohio so that it can be distributed the way it normally was before that happened. And so we're looking at this on a nationwide basis, trying to, I call it rewiring America. We're just having to change things, and we have to, the analogy I use sometimes is we're changing the fuse panel in our house from one end to the other. We got to now totally rewire our house because our electricity is coming in a different area. And that's not something you do overnight. It takes planning. And then the third part of that is we don't know that planning. We don't know where those wind farms are going to be 5 years from now. We're more in a reactive state where we just have to, wind farm's coming on. They're building a new one out in western Oklahoma. How are we going to get that power into Tennessee Valley?
Absolutely. Yeah, and that's the part that a lot of folks don't understand is just the sheer complexity of where you produce it is not, especially on the renewable side, is not where it's being consumed. And
the traditional role is you build a power plant where your population center was, and you have a very short distance to go to transmit the energy. Now we're not doing that.
Can't do that. And we're telling everybody to use electric cars on top of all that.
Yep. No, absolutely. I mean, California's grid, I think, hit above what they were expecting in peak demand this week. A year and a half ago, Texas saw catastrophic event on our grid here, related to just trying to predict and model weather and all those sorts of things that you're trying to do. And when you're at or near capacity, it doesn't take much to push you over the top. That's for sure.
I'd like to add one other thing, and that's just something that we all have to deal with the public.
Yep.
The very people that want wind energy, solar energy, renewable, they don't want the power line that's got to have to bring it back.
Yep.
And so people will fight for a renewable energy source, and that's great. But we got to have the extension cords that's required to do that. And getting those built with the permitting that's required these days, it's not unusual for a line to take more than 10 years to get permitted, and we can build it in a year.
That's right.
One of the other things, Otto, that I looked at with the winter storm event here in Texas is the difference between dispatchable versus non-dispatchable energy, and we're transitioning all of the generation to different forms of generation, but it used to be something that you could fire up the natural gas plant or the coal fire plant or the hydroelectric plant, flip the switch and it would come on. With wind turbines and with solar, you need that energy. You want that energy source, but if the wind's not blowing, when you flip the switch on, it's not there. And so you got to have a little bit of both. You've got to be able to make that balance, right?
Getting back to your international question, and it's something that we're learning from our friends in Europe right now. With the Russians cutting off the natural gas, and with their problems with renewables and everything else, they're now firing back up their coal plants. And what they don't seem to understand is that you can't just make a phone call and say, turn the plant back on. Yeah. They may not have coal at the plant. They may have already taken all the coal away. So we're going to have to get that coal there. You can't just call a train and say, have it tomorrow. I don't think FedEx will deliver coal overnight. Or UPS, pick your company. And then you got all the people that don't work there anymore. How are you going to get all those people back that run the plant? So it's not just flipping the switch. And what I fear about, we've learned some lessons from Texas, okay, and we should be learning a lot of lessons from Europe right now. And we need to have a balanced energy policy, okay. Renewable energy is great, but we can't just get rid of all the coal. We need to have that base load for when the wind isn't blowing, when the sun isn't shining, or when more electric cars get put online somewhere. We've got to have that base load still available. We shouldn't just be shutting down coal plants. We need to be sensitive to the environment. Don't get me wrong, but I think we need to be smart about it as well.
Absolutely. And you mentioned the electric vehicle transition that's just starting, Otto. I know you're a big car guy, and there's a lot of folks that will probably not drive an electric car for a long time. But, they're being built now, hundreds and hundreds of thousands. I mean, most of the major automakers are transitioning to almost fully electric. And that's happening very fast. I mean, within the next 3 to 5 years. It's not going to take much to think about millions of vehicles needing to be charged every night or during the day. Maybe speak to that as just from a capacity standpoint, what we're seeing happening on the grid or what's coming.
I think we should learn from California on that this week. Yeah. I mean, okay, we're supposed to, I'm not picking on them. I'm just saying this is something we should learn from. Okay, so we have to all be all electric by 2035. Oh, by the way, don't charge your cars tonight. Yeah. We need to learn from that and make sure that doesn't happen to the whole nation, and make sure that we have an overall energy policy to adapt to that. And, I don't have an electric car yet. When the Enzo Vet comes out, I'm getting one of those. I can tell you that right now. You heard about the Enzo Vet? No. Oh, we're going to talk about that later. Okay. Anyway, I'm not saying no, but at the same time, I make a lot. I drove 8 hours to get here. I don't want to stop and charge my car 45 minutes 3 times to get here. Yeah. So that for long trips, I don't want to do that. But at the same time, I want an Enzo Corvette, electric Corvette eventually, and. So I'm not opposed to them at all. I think they're great for short commutes and all that stuff. But I also think that, again, we need to be realistic and have a balanced policy.
And it just needs to be thought through, right? I think that's the thing is if we're going to have 2 or 3 million electric vehicles in the next year or two, we need to think how we're going to build the infrastructure to support it, because I think that's the key to it. We have a hard enough time siting. I mean, you mentioned it earlier. It takes 7 to 10 years to site a transmission line. If we start today, we're not going to have the infrastructure in place. If we get to, in the next 10 years, we get a significant amount of electrical vehicles.
We won't have it. And, right. We're talking about the macro scale, the overall transmission generation grid. Let's not forget about the micro distribution scale. A lot of new neighbors, but even new neighborhoods that were built less than 5 years ago, their underground distribution system was not designed for 2 Teslas in every garage.
Yeah. Yep.
It can't handle that load. So we're going to have to basically be digging up and rewiring even neighborhoods, even new neighborhoods, just to be able to handle, everybody charging their cars overnight.
Yeah, no, absolutely. Well, you guys talked to me a little bit about your committee leadership and in your bios. I mean, it was long with committees and subcommittees and all sorts of industry leadership. I think there's great opportunities, you guys as 2 icons that are helping really drive the industry forward. In a lot of ways. Maybe kind of give me a little bit of your history there, Otto, maybe what you tell young engineers kind of related to your committee work and how that is positive for our industry.
Sure. I like to sum it up in 2 quick words, and then I'll elaborate. Learn all you can learn, and get in the field. I mean, you mentioned other people have mentioned that before, and take it. Be like a sponge. Whatever your opportunity is, learn from it. And at Black & Veatch, I was a young engineer, but I had some mentors that that are very well respected people in the industry. Some of them have passed on, but I absorbed from them. Outside of the industry, even in Black & Veatch, I got to know people like like Wes, and I'm not going to name other names because I'll leave somebody out and they'll get mad at me, but I could just go on and on and on about all the people that I've met, and I ask questions. Can I take you to lunch? Can we go to dinner tonight? And I learn from them. So I just say that, just learn, take opportunities such as TS-DOS and the ASC ETS conference is coming up next month. Go to these conferences, and you're going to learn a lot sitting in the presentations themselves, but you're also going to learn a lot in the exhibitions and just hanging out and rubbing elbows with the people of the industry.
I think you're right. I think that for young people, putting your phones down a little bit and connecting with other professionals in the industry, it's so critically important, and to be able to interact, ask questions, learn from one another, because everyone's going through various challenges, and your challenge, or Wes, your challenge might be the same thing, and you've solved it one way, and you can help one another. That's something that I think we want to see more of, and we've all been set back a couple of years with COVID, where we've lost a lot of that interaction with folks, and certainly young folks that are coming up in the industry.
Well, I think we built a little bit of a culture too. We don't want to talk about things that have gone wrong, and that's a mistake. But we need to figure out how to do that, and so I think that's an opportunity for us as an industry if we would open up a little more. And I'm starting to see a little bit of that. I don't know if you're seeing it as well, but we're able to talk a little bit more about the problems of the industry than in the last few years.
That's a good point. The best way to learn is to learn from other people's mistakes. Right. And unfortunately, sometimes in our industry, people don't want to talk about their mistakes. They want to sweep them under a rug and pretend they didn't happen. And I understand that. Sometimes mistakes are embarrassing. Mm-hmm. But at the same time, if you can share your mistake, you're going to teach hundreds of other people not to do the same thing.
That's right.
And I am seeing a little bit of a change at the same time because of lawsuits and embarrassment or whatever. Sometimes there's like, don't tell anybody, let's get this fixed, and we'll move on.
We see it all the time, Otto, on the manufacturing side. We'll have a utility tell us, we're the only ones having this big problem. We're like, no, you're not the only one, because we can't talk to anybody else about it, right? And
we signed all these NDAs.
That's
we can't
it.
talk to anybody.
The lawyers get involved, and that's fine. Like you said, they're trying to make sure they're protecting their interests, but the industry loses because of that. And we've seen time and time again, people just repeat the same mistake over and over and over. Because no one's willing to share and discuss and kind of put their dirty laundry out there, and everyone learn from it.
A kind of a similar story, and Wes and I have talked about this many times before, but I'm going to go back to just engineering design, and I'm going to use wood poles as a perfect example. A lot of times people just follow a cookie cutter standard, mm-hmm. and use a pole, and then 3 years later it blows down in a storm, and they don't call the engineer and say, what did we do wrong? The lineman in the middle of the night, they do the right thing, don't get me wrong, but they just put the line right back up. Yep. And oftentimes they put the same size pole right back up. Mm-hmm. Why didn't we take the opportunity to maybe say, maybe we should make this line a little more robust? And then 3 years later, the same line falls down again, whether it be because of poor design to begin with, or lack of design sometimes, or maybe just geographical. Maybe it's a wind flow area where a lot of wind comes through. But there's lots of we just need to learn from that. But and I'm not picking on the wood pole. Don't get me wrong here. But with wood poles, it's a lot more easier to fix. Yep. So when you have that storm, let's just put the wood poles back up. Let's get everybody back on the grid, and that's good. I mean, mm-hmm. we want to get that restoration back as quickly as possible, but maybe a restoration plan should look at it in advance and say, hey, when we lose all these poles, those class 4s in that area, let's put class 3s in. Mm-hmm. Let's take advantage of that in the future. A little bit off topic from your question, but I wanted to get that in.
But it's a good point. I mean, again, and I've discussed this in the past with several folks, but we determine what we're going to do a lot of times, but by what's happened in the past. We need to be more projecting forward what we think is going to happen in the future. And if we think that weather events are going to get more severe, we need to be designing for more severe weather events than what we've done in the past.
Well, ASC 7 and by following the 74, the new loading standard for ASC transmission, we're going to be increasing the winds. And, not to get into climate change, true or not, I'm not going to get into that. I'm saying there is an increased wind. Yep. So let's design for the future. And we're one of the few industries that are doing that, by the way.
Yeah, no, absolutely. Trust us, us living in Houston, we've had like 4 500-year flood events and like 3 100-year flood events in a 10-year period. So certainly, just using what you've always done is not necessarily predictive of where we're headed. and trying to get out ahead of that, especially when you're building infrastructure that you're trying to have out there for 30, 40, 50, 60 years. I mean, you guys have to have a real vision of where we're going to be in 50 or 60 years. And, folks expecting 115, 120 degree, weather in California in September was probably not on the, not on the target list over the, last 10 or 15 years of trying to predict that.
As Otto said, there's ASCE has really taken a good lead in that, and the new ASCE 7 has actually extended the mean recurrence interval of winds out to, I think it's like 1,700 year mean recurrence event, if I remember correctly. Yeah. And that was, you think about that. That's thinking pretty forward. If you think you're going to be around, well, not that it won't occur for 1,700 years, but the statistics of it is that you're starting to think a higher and higher probability.
And compare that with what we traditionally have been doing with a 50-year.
50-year.
And obviously the 50 years not exactly working. So we need to, get away from. A mentor told me this once. We need to get away from what he called the Star Trek syndrome. To boldly go where we've always gone before. We can't do that. We've got to break that routine. We've got to think new. We've got to come up with better designs. And it's a two-way street or two-pronged approach on that too. Not only do we need to have a better design, but our society as a whole is expecting electricity more. Yep. More and more. They expect the lights to come on.
To be more reliable, more robust.
They want more reliable. If they get up in the morning and their car's in charge, they're going to be hot. Okay?
Well, like you said, Otto, you think about all the remote work going on right now, electrification of transportation, all of that makes the electrical grid an even more important backbone of society, right? And you can't afford to have it go down. I mean, it starts shutting down big chunks of the economy.
The interdependency is something I think a lot of folks underestimate, and we found that out in the Winter Storm Uri event here in Texas, and I think a lot of folks are starting to realize that there's a lot more than just putting the home lights on. You got gas compressor stations, you've got all kinds of infrastructure that are depending on electricity now.
I've talked about on the report card for America's infrastructure. Wes and I are on for ASCE. It's 17 different. I think there's 17 different. We're talking ports and roads and bridges and even schools is one of the categories. But we can kind of sit back and say all of y'all need to have electricity to operate.
Yep.
You don't have electricity, you're not going to get your water. Okay, your water tanks are going to empty eventually. Your wastewater plants are going to quit working, and you're not going to like that situation. Your traffic, maybe you can drive on a road, but none of the traffic's going to operate. And so it's easy for us to say this. Electricity is the backbone for all infrastructure.
No, it really is. Yeah, it really is. And there's really not much of a dispute on that, right? Telecommunications, like you said, water. Sewer, everything. I mean, everything. If you don't have power, you don't.
No, I think that's exactly right. I mean, even the cell towers, they have a little bit of backup generally, but it's not going to last more than a day or two. And so, if we have a prolonged power outage, you're going to be in deep hurt.
So, Otto, you talk a lot about kind of young engineers, and one of the things we're always asking, all of our guests on our Integrity podcast is maybe an experience in your life. Where either through good integrity or solid integrity you saw some success, or you saw someone do something that was did not have a lot of integrity and created a big problem for them or for the industry or for a client. Maybe walk me through an example there of how you view integrity in our industry and for yourself personally.
It's an important topic because us as engineers, you and I have talked about it a lot. Yeah. And probably why we're such good friends, because we have a lot of viewpoints that are similar in that regard.
I think integrity is summed up by one of the canon of ethics for civil engineers, and that is don't practice outside your area of expertise. I'm not going to go and try to size a transformer. That's not my area of expertise. Mm-hmm. And so by the same token, though, I think anybody that's going to be designing a transmission line should have, or a distribution line, should have expertise in that area. And, that's just, I did my 4 years of internship and took my PE test and worked my butt off. Can I say that? Mm-hmm. And I earned my PE. And I think that I wouldn't hire a doctor to be my doctor if he didn't have his doctorate, and I wouldn't hire a lawyer to represent me to be a lawyer if he didn't pass the bar. I think that would be illegal. I may be getting in trouble for saying this, but I'm going to go ahead and say it. We really need to stress the importance of a PE involved in a project to make sure that engineering principles are done correctly. Many times, that they even know about the codes that apply. I see that a lot. People will design and they don't even know that there's an ASE code that says how to design wood poles. That's scary, okay? So practice in the area of expertise, and then to kind of go to answer your question about a specific instance, and this is something that kind of rattled me for a little bit, but I see people, they buy our software and think they're just all of a sudden a transmission line design engineer overnight. And, I got your software. I don't need to know anything. I can just push F10 and get a line design out of it. And, it's not that bad. But what's even worse, though, is upper management will say, well, I'm going to hire an English major and buy them PLS CAD, and they're going to be a lot cheaper than an engineer, and they can go design all the lines. And so I was actually at a very small utility, and they didn't have anybody on staff that was qualified to be doing designs, but they wanted to buy the software, did the presentation and everything else, and I just didn't feel comfortable selling them the software. I was like, this is like giving a Ferrari to a sick teenager. You just don't do that. And I remember getting in my car and driving away, and I called my uncle, very, very wise guy, a lawyer, and now he's a judge, and I just said, Uncle Gary, what's going on here? And he told me something very wise that I have kept in my mind a lot since then. Sometimes your best clients are the ones you don't get.
Yeah.
And so he's like, they're going to cause you a problem later. Don't worry about it. So I didn't sell them the software, and that was out of an ethical reason. Yeah,
no, that's an awesome story, Otto. And I've heard all the stories of Wes over the years and other engineers that work for us. When they pull out their PE stamp to sign and seal something, it means something. That thing is going to be a record, permanent record. If there's a problem, you're the first one getting the phone call, right? And it means something more than just, hey, I've checked a box or I've done something, because you guys are putting your integrity and your education on the line every time you're PE sealing something. And I think that certainly matters. And it shows that you've put in, like you said, the work and the testing and the effort, and worked under great mentors to learn your craft so that you're able to seal something in that regard.
I think that's something that's actually changed for the better in our industry over the last 15 or 20 or 30 years.
It is changing, yes.
Because back when I first got in, utilities are exempt from doing engineering seals on things. But now you see more and more that are requiring it. So I think it's changed for the positive, and I think that's a good thing.
Absolutely. Well, Otto, we appreciate the time. It's been awesome chatting with you. And what you guys are doing as a business is fantastic for the industry. So we appreciate that. We appreciate your time and your insight. And it's fun for me to get to talk to two industry icons, get to work with one, get to talk with another. Makes it just fantastic for me. So thank you for your time.
Thank you, Zach.
Yeah,
thank you, Wes.
Thank you. Thank you, Otto.